Hello, welcome to this video. Greetings from Metaforum Technologies, Vadapalani. And in this video, I'm going to explain how to convert ER diagram into Oracle tables in Oracle. See, Oracle is just one database. You can use this techniques or the points that I mentioned in this diagram to convert ER diagram into tables for any database. It is not only applicable to Oracle, it is applicable to almost all the databases. Okay, now what is an ER diagram? ER diagram is entity relationship diagram. I'm sure people with computer science degree or IT degree, they would have heard about this entity relationship diagram for the database management system process. Okay. But I'm sure most of the guys will not know what is the use of ER diagram. See, the use of ER diagram is the most important concept in any database. Any database training, whether it is Oracle, MySQL, DB2, SQL Server, any database training without ER diagram is actually meaningless. Because of course when you work in companies, when projects are assigned to you, you will get to know about ER diagram and you need to convert this ER diagram into tables. See, it is used to get customer specifications, customer requirements. Once customer requirements or specifications are there, you need to convert them into actual database table. So these customer specifications are represented by this entity relationship diagram. It is the most popular data model. For database management systems. Okay, now what is an entity? Entity is any real world object. Any real world object is an entity. Whether it could be physical or it could be logical, doesn't matter. It must be unique. It must be unique in real world. Any entity that is unique in a real world is any object that is unique in a real world is an entity. And there are two types of entities. There could be entities like, let us talk about employee. Employee is an entity because every employee will be uniquely identified by something called employee ID. So that is why I say employee is an entity, physical. It's a physical entity. There could be something like university or project. There is nothing physical about university or project. It's only a logical thing, nothing physical. But even though they are physical, they are logical, they are also unique in the real world. So they can also be termed as entities. So entity is any real world object that has unique persons. Now in real world, these entities will have relationship with other entities. Okay, will have relationship with other entities, and you should study this relationship between entities, because the relationship is one of the major factor that, let us say, that converts that gets converted into table, right? So primarily there are four types of relationship. One is to one, one to one, one to many, many to one, and many to many. See, why we should study the relationship? Now it will get converted into table. See, for one to one relationship to represent, you just need one table. Okay. For example, I am telling you this. See, there is husband. There is an entity called husband. There is also an entity called wife in the matrimony table, right? So husband entity will have following fields or attributes like husband social security number, husband name, his address, stuff like that. And wife table or wife entity could contain these fields like wife social security number, wife name, wife address, stuff like that. And this is one-to-one relationship. See, at any given point of time in a matrimony relationship, an husband will have only one wife, and a wife can have only one husband at any given point of time. Okay, so it is a one-to-one relationship. Now you can have both husband details and wife details in the same table called matrimony. So there could be a table called matrimony. We'll have husband details like husband is social security number, name, stuff like that, and you can also have wife details like wife social security number, name, address, etc. So it doesn't matter, it's not going to affect anything because it is one-to-one relationship. Definitely an husband will have a wife and wife will have an husband, and one can have only one wife and she can have only one husband, and there is nothing wrong if you keep both the details of husband and wife in a single table. Suppose you want to use a different table, you can use it, but the query performance will be limited. So it is better, better advice to have both the details of husband and wife in the same table. Now, next type of relationship is one-to-many relationship. Okay, now to represent one-to-many relationship, you need to have at least two tables, and many to one. It is also same. So you need to have at least two tables. For example, employee works for department. Now employee is an entity, department is an entity, and works for is a relationship. Now employee at any given point of time can work in only one department, and a department can have a number of employees. So it is many to one relationship if you see from this side, or it is one-to relationship, one-to-many relationship if you can see from that side. Irrespective of that, you need at least two tables. So one table will have employee details like employee ID, employee name, salary, etc. And another table will be for department. We'll have department number, department name, location, number of employees working for the department, stuff like that. Now, so okay, before proceeding further, why you need two tables? I'll tell you this. Suppose I'm going to use a single table called employee underscore department. So it will have all the fields: employee ID, employee name, salary, department number, department name, location, and number of employees. All the details in the single table. Now, what could be the problem? The problem could be, I call it anomalies or problems. So it could be of different dimensions. For example, let us say insert. That will be a problem when you insert. So if we have employee and department details in the same table, what could be the primary key? Together employee ID with the department number will be the primary key, right? So this table will be having two attributes combined into a primary key. Employee ID and department number is the primary key. Now you cannot insert an employee detail unless otherwise he is working for at least one department, right? Are you getting the point? Again I repeat, you cannot insert an employee detail unless otherwise you work for at least one department, because department number cannot be empty, because department number is also part of primary key, so it cannot have null values. So normally when you insert an employee, initially you will not be assigned any department or project, so this is a problem. This is called insert anomaly. And next could be delete anomalies. Let us say a particular department is having only one employee. Okay, if you delete that department detail, the employee detail will also get deleted. Okay, so if an employee works for only one department and the department also has only one employee, now if you delete the employee details, department details will go. If you delete the department details, employee details will go. That should not be the case. That is a problem. That problem can be classified as delete anomaly. The last type of anomaly is update anomaly. Suppose a department is having 100 employees and you are changing the location of the department. So 100 times you have to repeat this process. So it is waste of resource. It's called update anomaly. So if you have all the details in single table, you will have all these anomalies, and that is why you should not have them in single table. So that is why you need two tables, employee and department. Now, For employee entity or employee table, department entity or department table. What about the relationship works for? There exists a relationship between employee and the department, right? So how do you represent the relationship? Either you can put employee primary key in department, that is employee ID in department, or you can put department number in employee. Both are correct only, but for performance reasons, we always put in the many side, that is in this case employee side. So department number should be put in the many side. So employee works for a department, and department name is this, location is that. So that is how you have to represent one-to-many relationship. That is using two tables, and many-to-one is also same example, and many-to-many relationship. So you need most probably three tables, because many of the many-to-many relationship will contain something like identifying attributes, identifying attributes, okay, and so you'll have employee, and you will also have employee table, will have employee ID, employee name, salary, like that, and employee is having a relationship with a project table, that is employee works for project entity. Project will have project ID, project name, and location. So okay, now the idea is an employee can work for many projects at a given point of time. A project can also have many employees at a given point of time. So many to many relationship. Now an employee works for particular number of hours in project A. Okay, let us assume an employee with ID 100 works in project A for 10 hours. The same employee 100 for project ID B work for 20 hours in a week. So number of hours an employee works for a particular project in a week should be mentioned. Where will you mention? Will you mention in employee table or will you mention in project table? See, you cannot mention in project table because number of hours depends on the employee, and you cannot mention in employee table because the number of hours this guy works, an employee works, purely depends on the project that he is involved in. So number of hours cannot be placed in employee table or for that matter project table. So you need to create a separate table. So for many to many relationship, you will have one table for identifying entities. In this case, employee and project. And you need a separate table that will have primary keys from both the tables, employee ID here and project number there, together with the identifying relationship. In this case, it is number of hours. So that is why you say many to many relationship most probably will require three tables. So when you talk about Lear model, the type of relationships one to one, one to many, many to one, many to many plays a major role in identifying the number of tables. Okay. Next factor that could identify number of tables is let me say participation. There are two types of participation, total and partial. If an employee, let us say total, if all the entities will participate, then it is in a relationship. In a relationship, then it is total participation. Only few relations or few entities participate in a relation, that is partial participation. Now this total and partial participation. Now in total participation, and also the type of participation, that is total and partial plays a major role in number of tables. For example, even if it is one-to-one relationship, let us take an example for one-to-one relationship. Instead of matrimony, I am going for relationship status. There is a table called relationship status of students. A dating website can have a relationship table, right? You'll have like mail ID, you'll have like female mail ID, mail name, or customer ID, custom name, customer ID, customer name, partner ID, partner name, etc. Other details of both customer and partner. Partner in this case is for it represents our spouse, or let us say people that we are in relationship with. Now, the participation in this case between the customer and his partner, in case of students of an university, could be, let us say, partial, because not all the students are going to be in a relationship. There will be students who will be in relationship, there will be students who will not be in a relationship. So some students will participate in the table relationship, in the relationship table, and some will not participate. So if a guy is not going to have a girlfriend, let us say for example, then a partner ID name will be null value. Partner details will be null value. So if there are more number of guys who are not going to have some partners, that means there are more number of null values. That is not at all advisable. In that case, you will have separate table for the students. Okay, so that is how it should work. So whether it is total or partial in case of entities participating in a relationship also determines the number of tables that you are going to use in your table. Other than this, what could be the other factors? Let us say, I would say attributes. Like if you have complex attributes or composite attributes like address, or multi-valued attributes like hobbies, these things require separate tables. Okay, and what could be the other factors apart from attributes? Could be normalization. Okay, so it depends on the normalization. So these are, you convert your Lear diagram into tables. Briefly summarizing in a minute. Entity is a real world object with unique value, and it can have relationship with other entities. Relationship could be categorized into 4 types: one-to-one, one-to-many, many-to-one, and many-to-many. And one-to-one relationship requires 1 table generally, and one-to-many and many-to-one relationship requires 2 tables, and many-to-many relationship requires 3 tables. And other than this relationship, the number of factors also can, number of tables from this here can also be determined by other factors like normalization, type of attributes, and also the participation type. So ER model is the most important concept that determines the number of tables that are going to use in your database. So thanks for watching this video, and for the best database training in Oracle, SQL, PLSQL, DB2, MySQL, you can contact Metaforum Technologies. We are located in Vadapalani, Chennai, and this is Shankar, and I can be contacted via 56 54 7 543 for training in database, and I can be reached via Shankar at Metaforum Technologies.com. So if you have any doubt regarding this, you can always contact me via this mobile phone or email ID.